Right, page 4. All right, here you go. In previous years of math, you've learned how to solve for missing angle sides of right-angled triangles. But what about triangles that are not right-angled? In order to solve them, right, these are called oblique. Not right triangled are called oblique. Right? Not right triangles are called, we call them oblique. They all fit the category of oblique, not obtuse, oblique. We need some new tools. The first tool, right? You need new tools. The first tool is going to be the sine law. And I will say this though. Can I go to the very front page cover? Don't use SOHCAHTOA, okay? Let's go to the very front because it happens on the exam. You freeze and then you go back to what you've learned in grade 10, 11, right? So note, I will just tell you flat out, don't use SOHCAHTOA. If this is sine, cosine, tan, and these are the sides, because most 99.9% of the questions are not going to be right triangles. And if there are right triangles, we're still going to use sine law, cosine law. Okay, so forget about SOHCAHTOA right now. Back to page 4. You're going to have to pay attention. Once you get it, it's going to be all right. Okay, given the oblique triangle XYZ below, the sine law states that the following is true. Sine of angle D, watch this, sine of angle D over side D, so this is a pair, right? These are paired up. Why don't we use a highlighter for that? Okay. So this pair is right here. That is equal to sine of angle E, which is over here, over the side that's across from it, which we call lowercase e. Okay, so there's your E. And then we have sine of angle F over side F. That is also going to be equal. So this is true in any triangles that you're getting. Okay. Notice that it's not just saying D over D, it's saying sine of angle D over its side, sine of angle E over its side, sine of angle F over the side that's across from it. That's very important that you keep that in mind. I will box this in. You're like, what? There's 2 equal signs, Mr. Dirksen. That looks pretty scary. Don't let that scare you. We're only going to ever use 1 equal sign. But this is just true about any triangle you ever get. If you were to actually compute that, if you knew all sides and all angles, and you were to do this, every single value would be identical. Okay? And it works with the following scenarios. So this is when you have an angle and the side across from it and any other side, let's call this one here, that's an SSA, side angle. Don't worry about what we call it too much. It's not going to be, I'm not going to ask you to remember that, but in the math world we do have that. The other one is, let's say you have a pair. You have an angle and the side across from it, and you're given one more angle. Okay, that would be an angle, side. Okay. And then the next one is angle, the side, and the angle. Okay, you have angle, side, angle. And I want you to notice something. This one, you can see that there's a pair of known, right? The angle on the side, that's a pair. Perfect. I want you to notice the pattern. This one here, if you look at this triangle, is there a pair? Yes, you have the angle on the side across from it. So that is a pair. Does this one have a pair at first glance? And it may not seem like it, but I'll tell you this. I'll call this the hidden pair. Hidden pair. Let's put the pair over here. This one has a pair. This one has a pair. So pair, pair, hidden pair. Why is it a hidden pair? Well, because if you have two angles, you can easily find the third one. Okay? Calculate using sum of triangle is equal to 180. And then we can put a check mark there and say that that one is also now a pair. It's a hidden pair. And why am I focusing on pair, guys? Here's the disclaimer. This is what I'm going to tell you first and foremost. Remember, if you have a side angle pair, then use the sine law. That's highlighted with the same color as I highlighted all the pairs. This is what you need to remember out of everything we've talked about so far in regards to sine law. If you have a pair, you're going to use sine law. Just remember that. Is obvious, not so obvious because you're not going to see the pair. But if you have two angles, you can easily find the third one. Always. Because we know that all angles add up to 180 in a triangle. Okay. So this is a little bit of a intro to that. So let's put it to the test here. And then I'm going to ask you to try it almost right away. So let's go over to page 5. So this is where you want to pay attention. If you were dozing off, if you're on your phones, right? Like, make sure you pay attention to this part because it'll make your life a lot easier. I restate the sine law right here, what it does. What does it ask me to do? So we're going to first do side lengths, okay? First side lengths, then I'm going to show you how to solve for an angle. But it says calculate the length of side A. Side A, even if this hadn't been there, even if that was gone, you should have known, hey, that's angle A. Therefore, we're asked to solve for this side. Okay, so we're going to put a question mark there. That's what they're asking me to solve for. And this is partially filled in. Is there a pair here? You have an angle, a known angle, and a side across from it. And you should see that the answer is yes. So, hey, that's my pair. Pair. Use sine law. In a day or two, I'm going to introduce cosine law. We're only going to ever use sine law or cosine law. Those are the only two options you're going to have. If you have a pair, it is guaranteed sine law. Okay. What I do with this is I start with my pair always. So I go like this. Sine of angle 52 over the side length across from it, which is 16.8 centimeters. And then I say, okay, what else can I do? That is equal to, it's going to be another fraction. And you look, and you're trying to solve for side A. Remember, this is also a pair, but this is not known to us. So since I want to find this side, I'm going to use this angle over here to help me find it. So you write down sine of 72 over side A. This is unknown to us, like that. That's how you set it up. This is your pair. And since you wanted to solve for this side, you had to use that angle up here. It is a proportion. Yeah. It's exactly what it is. So here we go. Now we solve it. Guys, remember, you go to the side where the unknown is. You start with the number. You're like, that's sine of 72. That's letters and numbers. This turns into a number, trust me. So we're going to go cross multiply. Just do this for your notes. I don't want this necessarily in the work. And then divide. Okay, that's how we're going to solve for side A. So here's how I want you to show me this step intermediate here. So basically we just show that we multiply these two. So I go 16.8 times sine of 72. And then I will divide my answer by, right, this is what's left, by sine of 52. And this is where you need to use your calculator and become really good at it. You have to use your calculator, hopefully, to get this. So here we go. Mr. Dirksen, why didn't you put sine of 72 first and then 16.8 next? Like when you write this out, why is that? I'm just careful because watch, if I go sine of 72 times 16.8, like if I type it in like that, I'm scared that the 72 is going to multiply and then the sine is going to happen. So to avoid that issue, I first start with this number. As long as you multiply these two, you're fine. 16.8 times sine of 72, I hit equals there. And then I go divide it by sine of 52. And some of you, I might have to help you out with your calculators, but this ends up being 20.28 centimeters. 20.28 centimeters. Hold it. Does my answer make sense? This is what I want you to remember. Right here. Note the longest side is across the largest angle. Therefore, the shortest side is across the smallest angle. Always keep that in mind. So let's look at the logic here. 52 degrees has 16.8 across from it, right? This one is 72 degrees. We would expect the side across from that to be longer than 16.8 because it's a bigger angle and it's checking out. So I always want you to ask yourself, does my answer make sense? Right? And think about it. If the angle is bigger up here, right, the bigger the angle, the longer the side across from it is going to be. Okay. All right, so let's write that in. I'm going to take the 20.8, the 20.28, and just write that in with a different color, because now I know what this is. Okay, it's important because sometimes you want to continue solving for everything else. So here we go. Let's do that. Calculate the length of side C. They want this. This is what we want for our second step. But there's a problem. We don't know what this angle is. We can find that angle, right? If you have two angles, you can find a third angle, no problem. So let's go ahead and do that. I'll make a note here. we need angle C in order to solve for side C. You need the angle across from it. That's imperative. So I'm going to say angle C is 180 minus 52 minus 72. So I'm subtracting the two angles that I have. So you grab your calculator, 180 minus 52 minus 72. That's 56 degrees. So angle C is 56 degrees. I'll write that down just to make sure, right? It's not our final answer, but it is important. And watch this. I'm going to start with the same pair as before because this never changes. So watch, I'm going to go sine of 52 degrees over 16.8 because this is a known pair to me that's given to me by the question. And then I'm going to go equals. Let's write in 56 in our triangle just so we know this is what we solved for. Okay, 56 is right there. I can now say, hey, sine of 56 degrees is going to give me the side across from it, which is side C. And I'll put an arrow showing that I did that. And same thing. You cross multiply and divide. So you go 16.8 times sine of 56 over sine of 52 degrees. And that is C. It's a little bit bigger than angle 52, right? The one we were given. It's a little bit bigger, so we're expecting our answer to be a bit longer than 16.8. So here we go, 16.8 times sine of 56 equals divided by sine of 52. 17.67 rounded centimeters. That's what we're at. Boom. By the way, we solved the triangle. Do you remember that term? Solving the triangle? All sides, all angles. We essentially solved the triangle because now we know every single side and every single angle of it. Okay, we're gonna put it to the test here. See if you can. You know what? Just practice, okay? Google. If you listen to Google and the people that work on AI, artificial intelligence, I know that's like it's gonna be doom for humanity if we don't do something about it soon. But you know what it does? It learns from its mistakes, right? It's like an exaggeration of what we should be doing, but it's like it'll make 1,000 mistakes before it gets it right. But it doesn't care about making mistakes. It just says, okay, I'm not going to do it like that anymore. I'm going to try something else, right? So I want you to try, go to page 6, and how about you just try A for now? Just question A. And when you're comfortable, you go B, and then you go C as well. So let's go to page 6. I'll give you the answers right away because I feel like you need to know what you're supposed to be getting. And I'm just going to show you here. You see the pair. There's a pair right there. It is sine law. It's asking you solve a triangle means to solve all sides, all angles, right? Check if answer is reasonable. So I want you to start somewhere and see what you can solve first and then move closer into solving everything else. So side Z, you're supposed to find You're supposed to find angle X at one point, and you're supposed to find side X also at one point. And I will give you the answers here. Z is 624.91 meters. Side X is 1315.01 meters. And angle X is 33 degrees. So for now, that's all I'm going to give you. I want you to try this. Use your space wisely, like do some here, and then maybe do some here. It's up to you. But you're going to need the space for the other ones as well. So give it a try. I will